For the longest time, the classroom has pretty much stayed the same, right? A teacher up front, students taking notes, lots of memorizing. But that's all changing, and it's changing fast. We're right in the middle of this huge shift to a completely new way of learning, one that's way more hands-on, interactive, and all powered by technology. Let's dive in and see what that actually looks like. So, just look at this contrast. On the left, you've got the classroom a lot of us probably remember, all about the textbook, the lecture, and just memorizing facts for the test. But on the right, that's where we're going now. It's a huge move away from just passively listening to actively doing. And this isn't just about having cool new gadgets in the room. It's a completely different way to absorb information and build a real, deep understanding of things. All right, so let's start with the big picture here. We're at a point where technology isn't just some extra tool you wheel into the classroom anymore, it's become the actual engine driving education. It's changing not just how we teach, but the quality of the learning itself.
For decades, education was kind of like a one-size-fits-all assembly line. Every student got the same stuff at the same time. Well, technology is totally smashing that model. Now we can have personalized learning, tailoring the lessons and the speed to what each student actually needs and how they learn best. So everyone gets a journey that's just right for them.
Okay, so personalization is one huge piece of this puzzle. But how does technology actually get students to, lean in and really engage with the material? This is all about making that shift from being a passive observer to being an active participant in your own learning. So what does this active learning actually look like? Well, it's powered by all sorts of cool tools. We're talking about gamification, using ideas from video games like points and friendly competition to make learning feel more like playing. It's VR and AR that drop you right into these incredible immersive worlds. It's online platforms that let students work together on projects no matter where they are. Every single one of these tools is designed to turn the classroom into a space for real discovery. But let's be real. Interactive is a buzzword that gets thrown around a lot. What does it actually feel like for a student? I mean, beyond all the cool tech, what's the real, tangible difference it makes in their day? The difference is absolutely massive. Interactive means you stop just passively reading about a concept and you start actively doing it. You get to experiment, you get feedback right away, and you make these abstract ideas something you can almost touch and feel. It's the difference between reading about how an electrical circuit works and actually building one yourself and seeing that light bulb flick on. That's a whole other level of understanding. Now let's really zoom in on one area where this is a total game changer: science education. For generations, there have been these problems that were just part of learning science. But it turns out technology is perfectly suited to solve them.
Just think about it for a second. How do you really wrap your head around how molecules bond together, or what a magnetic field actually looks like, just from a flat diagram in a textbook? So many of the most important ideas in science are literally invisible, which makes them incredibly hard to grasp by just reading a description.
And then you've got the safety issue. I mean, some of the most exciting experiments, the ones that really get you curious, might involve chemicals or reactions that are just way too dangerous for a typical school lab. So that creates a barrier, right? It keeps students from really experiencing science in a direct, hands-on way. And finally, there's the big one: cost. All that sophisticated lab equipment, all the materials you use up, it's expensive. And what that means is that access to really great experiments is often limited, creating this gap in opportunities from one school to another. So, we've got these three huge challenges, right? Things are invisible, they're dangerous, or they're just too expensive. Well, the solution that pretty much solves all three at once is the virtual lab. So, what is a virtual lab? It's basically a fully interactive 3D simulation of a real science laboratory. It lets students run super complex experiments without any of the real-world limits. There's no risk, no budget worries, and no time constraints. It's a total game changer. And when you put the two side by side, the advantages are just crystal clear. Safety goes from being a major concern to a complete non-issue. Access goes from being stuck within the school day to being available 24/7 from anywhere. But maybe the biggest thing is repetition. In a real lab, you might get one shot at an experiment. In a virtual one, you can try it 100 times, fail, tweak things, and try again until you really, truly get it. So what's it actually like to use one? The process is super simple but incredibly powerful. You can tweak the variables, you run the simulation, and you see the results instantly. But the real secret sauce is being able to analyze all that data in real time. It's basically the scientific method, supercharged.
And look, this isn't some far-off sci-fi concept. Companies like PraxiLabs are already making these incredibly realistic 3D virtual labs for physics, chemistry, biology, you name it. This technology is already being used in classrooms, giving students and teachers access to experiments they never could have done before.
So let's pull back again and look at the really big picture here. When you start removing all those old barriers to hands-on learning, you're not just making a lesson plan a little bit better. You're actually creating a whole new environment for learning without limits. So here's the bottom line. This kind of technology makes those invisible concepts totally visible. It builds a strong bridge between classroom theory and real-world application. And maybe most importantly, it removes the physical and financial walls that have held back scientific curiosity for generations.